a normal approximation one. The one that I tried to do it was number 2, normal approximation to the binomial. So we're going to continue give you the other ones. So the topics that are going to be on that, I think I gave you the topics the other day, okay? So that is the topics that's going to be on the test, okay? This is the one that I repeated the other day. And you must know information regarding the z-curves and your quiz. Normal distribution, inverse normal, application problems, distribution of a sample mean, P of X bar, normal approximation to the binomial, confidence interval when the sigma is known, and the confidence interval when the sigma is not known, and the minimum size, okay, the minimum sample size problem. So that's the topics that are going to be covered. And you have all of them on this review. So you don't have the normal distribution, you have to check your quiz. Okay, so in fact, the first one is that inverse normal that we did on the quiz, the application to types problems. So that's it. It's going to be our practice test number 3. Okay, the first one is kind of those application problems or the inverse normal problem that we're going to have. Okay, inverse or in, this is if you want to use calculator. Okay, normal problem, like the warranty, the one that we did on the quiz. And in this problem, they're talking about the warranty for a TV set. Okay, the average life of the TV is given is 8 years, and the standard deviation is 1.5. So the company would like to place a warranty time or guarantee times, but they want to make sure that they are not going to replace more than 10% of the TV sets. So you have to design the problem. Okay, so this is it. If this is going to be your curve, because you have a normal distribution, this is a normal distribution. So what you would like to do is you would like to get a number. You see this is going to be a number, which is going to be the warranty that you're going to set. So for example, if you set 4 years, 5 years. So the company should replace the TV sets if anything happened to it up to the 4 years. Okay, up to the 4 years means if anything happened to your TV set tomorrow, they have to replace it. So if this is going to be the time that we're going to be finding, so this would be the area that the company would like to make it as small as possible. So the company would like to make this area to be something like 10% only. So from the probability point of view, this means you would like to find a number. You see, you would like to find the X naught, a number such that the area to the left, P of X less than X naught, you want it to be equal to the 10%. 10% is like 0.1. Okay, this is how you set up your problem in order to find it. So what you're going to do, you are going to go to the z-score and you find the area of the 10%. The number corresponds to the 0.1. So if you can do it with your calculator, but you have to set up the problem as is. Then you start working with your calculator, or you just go to the z table and check for the 0.1, which is going to be kind of 10% that we're going to be interested in. Okay, you just check the table to start with the 0.1. So you're not going to see it on the positive, you go to the negative sides. And where are you going to see for the first time 0.01? You see the 0.01, it starts with a negative 1.2, so it's a 1.0111. Try to get it as small as possible. So the smallest one is this one, 0.1003. So this is going to be like 10% that you have, and this corresponds to the z number of negative 1.2. Okay, and that's 8. negative 1.28. So in the language of the Z, this would be the number that we're going to get. Over here is going to be Z or Z naught. The number that we're going to be looking for is a negative 1.28. But you have to change it to the X. Okay, to change it to the X, you can use the Z formula. Z is equal to the X minus mu over sigma. And in the problem, the average is given to is 8 years, and the standard deviation is going to be 1.5. You substitute, so it's going to be negative 1.28, which is going to be equal to the X is missing, minus mu, which is 8, divided by sigma, which is 1.5. You cross multiply, so that gives you X minus 8. X minus 8 equal to the 1.5 times it by negative 1.28. Okay, so your X would be 8 plus, or you just multiply this one. You can use your calculator to multiply what is going to be. You see, if you multiply those two numbers, so it's a 1.5 times it by 1.28. Okay, so that'll give 1.92. It's a negative number, so 1.92. So X would be almost 6. So that give you 8 and 0, 6. Okay, so we can call it 6 years. So your warranty time would be 6 years. So if they set the time to be for 6 years, then they are going to replace only 10% of those TV sets, if you like. Okay, any question? Now, if you want to do it with your calculator, you have to set up the curve. You have to explain it that you are looking for this number, and then you can use the inverse normal. You see, this is the one that we did. So what we need to do, we need to go to the distribution. So the second distribution. So you need inverse normal, number 3. You see, that's it. Number 3 is inverse. So 1, 2, 3, that's inverse normal. So you click on this and they ask for the area. Area is 10%, 0.1. Then they ask for the mu. Mu is, the mean is 8. Okay, so that would be 8. And the standard deviation, okay, a standard deviation of 1.5. 1.5. Then you are going to paste it and ask it, and then this is it, 0.07, 6.07, 6.07, which is the same as the, almost the one that we did. We have 6.08. Okay, so again, you explain the problem, you have to relate the problem, and then you can do the operation and we accept it right away. But it's not going to be even difficult to do it by calculator. Any question? So that's the important part is this is the one. You see the 10% is the area to the left. Okay, just make sure you don't miss that area. So that's going to be number 1. Any question? So that's a number 1. Number 2, we did it, normal approximation to the binomial. Okay, that's a problem that takes a little bit time because you have to check the condition and let's just keep going. Okay, so we go to the number 3. Number 3 is going to be the next topic that we have. Number 3 would be a P of X bar in distribution of a sample mean. Okay, so this is the problem related to the P of X bar. So you read the problem carefully. It's going to be a 2 parts problems. So what we have here, you see we're checking the mean heights. So the information is that assume that the mean heights are normally distributed with a mean of 68 inches, 68 inches and the standard deviation of the 3. Then what we are going to do on the first part, we pick 1% out, 1% out. So the sample size is 1. And we ask the question that we find the probability that the height of that person will be between 67 and 69. But in the second part, we get a group of people, sample size 16. Then when you are in the group, you have to talk about characteristic of the group. So we're going to have to answer the same question. That's going to be probability of the mean height. Okay, the first one is just the height. The second one is the mean height. Okay, so it's a straightforward problem, but you have to nicely arrange it. Okay, so the arrangement is that it's a normal distribution. Normal distribution with the mean of the 68 inches. Okay, that's a 68. And the standard deviation of the 3 inches. For the part 1 of the problem, the sample size is 1. You pick 1% out, and we ask the probability of that person height is going to be between, so 67 less than X and less than 69. That's the first part. In the second part, the sample size would be changed. You are going to have a group of people, in this case, the sample size 16. So they ask the question about the mean height. So this is the same number, but this is going to be X bar. Okay, so the first part is P of X. The second one is P of X bar. Now we go for the first part. You know that it's a normal distribution. It can be done with the calculator right away, but we have again to explain, to set up the problem, but we're going to do it. So for we stay with the first part. That's it. You want to find the probability that X would be between 67 and 69. You have to find the z-score of these two numbers. So call the first one X1, 67. So the z-score is going to be X minus mu over sigma. We substitute, your X is 67, mu is 68, and the sigma is 3. So that give a negative 1/3. You divide it by 2 decimal places. So that give a 0.33, because it's going to be 33 forever. Okay, go there for the second one, X2 equal to the 69. So the Z is going to be this time X 69 minus 68 over 3. So that give a positive 1/3, which is going to be 0.33. Okay, so the problem would be changed into the Z format, and you want to find this probability. Z is going to be between negative 0.33 and the positive 0.33. So it's going to be area between two Z numbers. So this is going to be the case. So the numbers that we have are going to be negative 0.33, and you have a positive 0.33. So you are interested in this region. So we go to the table and you read these two numbers from your Z curve, if you want to do it. Okay, 0.3, this is 0.3, and the 330.123, 0.3707. So that's going to be 0.3707. Then you go to the positive side and you get the 0.33. And this is 0.30123, 6293. So that gives you 6293. So you subtract that to get your probability. Okay, so eventually the probability of the original one, that probability that the height of one person is going to be between 67 inches and 69 is going to be equal to the 0.6293 minus 0.3707. And if you subtract it, that gives you a 6, 8, okay, 6, 8, 5, 2. I think that's one. It's going to be 25.86%. The final answer. Any question? That would be the part one. Of course, you set it up. If you want to use a calculator, we can check it to see that we got it right. So this is it. We have go to the distribution this time. Okay, the second and the distribution here. Okay, that's it. Distribute for the second. So now you have to go with the normal curve. Okay, normal CDF. Number 2, you click, they ask for the lower. The lower one is, the original one is 67. Okay, lower one is 67. Then you see that is lower. And we go to the upper. Upper is 69. Okay, upper is 69. You keep the mu. Mu is 68. 68 and the sigma of 3. Sigma of 3, you paste it and you get the result. That's it. 0.2611. 2611, 26.11%. I have 25.86. Double check. It's close. It's not going to be exactly the same, of course. I may have made a mistake or somewhere. 7 out of 3 would be 6. I get 1, 8. Then 7, 5. No, it's almost the same. It's a 26%. Okay, so this is how we're going to do it. That's the first part. Any question? So in the first part, we're just focusing on the variable x. In the second part, you are going to have a sample size of 16. Then your x would be changed to the x bar. You know that your z would be x bar minus mu over sigma over radical n. So you have to change, going to the second part. So for the second part, you are going to find what is the probability that 67 less than x bar less than 69. So again, you have to find the z score, but your formula is different. Your formula for the z is z equal to the x bar minus mu over sigma over radical n. And remember, the sample size was 16. So find the z score again. So in this case, it's going to be x bar 1, which is equal to the 67. So you have the z1, which is equal to the x bar 67 minus the mu was 68 over sigma over radical n. Okay, so I just double check. The sigma was 3. So that gives you 3 over the square root of 60. So the top is going to be the same. It's going to be -1, and this is going to be 3/4. You flip it, it's going to be -4/3, and the -4/3 would be -1.33. Okay, it's going to be the 1. So x2 bar is 69. So we go with the z2. Again, the top would be x bar, which is 69 minus 68. And the bottom one is going to be 3 over radical 60. So this time you're going to have 1 over 3/4. You flip it into the 4/3, and you get a positive number, 133. Any question? So now the z score formula is this one. You want to find the -1.33 z and the 1.33. If you want to use calculator, you can do it now. You got to be careful if you want to use calculator, because you have to change the sigma for the second part. Sigma over radical n, you have to find it. So that would be the difference. Otherwise, you can use the calculator at this level. Okay, so this is going to be the case. negative 1.33, and the 1.33. Go to the table and you find these numbers. For the Z table, negative 133, this is negative 13. Okay, 0, 1, 2, 3, 0.0918, 0.0918. That is for negative 1.33. For the positive, okay, that would be positive 1.33. That's a 3 here, 0, 1, 2, 3, 0.9082, 908082. Okay, you subtracted that, give it the result. So the probability that the mean height is going to be between 67 and 69 is going to be the difference. 9082 minus 0.918. And you subtracted, so that gives you 4. And that would be 6. And this would be nothing. Okay. And this would be 9. I think that's true. So it's going to be very large number, large percentage. 90.60. Okay. So this is the case that we're going to have. So I double check it. So I have a point, that's a 0.9082. That's a minus 0.0918. Oops, what I missed. 8164. Okay, I have a 0.9082 minus 0.018. So that would be 81.6064. 81. Yeah, that would be 80. But yeah, I missed something. It's going to be 81. Okay, 81.64%. That would be 81. Okay, this shows that, when you are going to be in a group, the possibility is higher that you are going to pick something, yes, right on your right. Okay, so if you are just a single person, so the likelihood is low. But if you are in a group of people, so the average height may be having a better possibilities. Any question? So if you want to use your calculator for the second part, you got to be careful. And you have 2 choices. If you want to stay with the original one, you have to change your sigma from the first part, sigma over radical n. But otherwise, you can go with we can find the z and the z, okay, and then do it. You see, this is your options. If you want to use your calculator, so we go to the distribution and the normal CDF, that's a normal. You see, we already got the lower of the 67 and the 69. So these lowers are the same. But when you go to the sigma, you got to be careful. Because your sigma for the second part is what? Is sigma over radical n. So your sigma was 3 over 3 divided by radical n. N was 16, so the radical n is 4. You see, everything else is the same. So that gives you the final answer. I didn't get it, so I have to do it again. So that's a normal CD. So I have a 67, 69, then the mu of 3/4, and the standard deviation of the 3. Everything seems to be all right. maybe that three quarter. So that's a 67, 67. So I change this one into the 3/3. It should be 75. So the standard deviation of the 3 and the page. No, there must be something wrong that I won't get it. Because I get 0 here, which is not correct. Okay. So what's wrong with this one? We get the normal, which is correct. So, oh, that is the lower 67. I repeat it again, lower 67. So the upper is 69. That's a 69. So, oh, I made a mistake here. That's it. That's a mu. Sorry. That's a mean. What does the mean? 68. The mean of 68. I made a mistake here. The mean 68. Yeah, I should change the sigma. Sorry. I should change the sigma into the 0.75. You just change the sigma for this case. That's it. 81.75. Okay, 81.75. Almost forget. 81, 60, 64. Okay, so be careful. If you want to use the second part, you have to change your sigma because the standard deviation, the mean is going to be the same, but the standard deviation would be different. Yes. Okay, so this is the case for the sampling distribution of a sample mean. Very standard problem. You can't miss it. 2 parts, even without calculator, it can be done quickly. So you can't miss it. In the first part, we pick 1% out. Okay, the sample size is 1. In the second part is, how do you know ST is 0.65? You know the sigma, you see that's it. In the second part, the standard deviation is what? Sigma over radical n. And the sigma was 3, n was 16. So that gives you 3/4. 3/4 is 0.75. Okay, so you got to be careful for the second part. Because for the second part, remember, we divided by what? We divided by sigma over radical n. So that's going to be your sigma. The mean is the same, but the standard deviation is different. Okay, so be careful. This is the only one that if you want to use calculator, you have to change. Okay, so this is our distribution of sample mean problem. Nice one for the test, one for the final. If you don't have anything else for that section that we cover. Okay, so this is a distribution of sample mean. Next is going to be confidence interval. Okay, that we talk about it. So we are going to have a confidence interval for the mean. We are going to have 2 different cases. The case that the mean is given to you, okay, and the case that the sigma is given to you. Sigma is given to you, and the sample size is large. And the case that the sigma is not given. If the sigma is given, we are going to use the z-test or the z-interval to estimate. If the sigma is missing, we have to do the sample. Okay, so altogether 4 questions from this concept. So let's start with number 4. I go to the next page to explain more. Okay, so that would be our first problem on the confidence interval, number 4. So if you like, the subject in this case is going to be sigma is known. Okay, sigma is known, and in this case, E would be ZC sigma over radical, and that's the idea of this type of the problems. When the sigma is given to you, your marginal error would be ZC sigma over. Okay, we read the problem, and we ask the problem asks for the 99%. You see, this is it. 99% confidence interval for the population mean of blood plasma volume in male firefighters. if the mean is 45 and a sample of 45 people, they have the mean of 37.5 and a standard deviation of 6.70. Okay, so you find out that this problem is about estimating the mu, the mean. So I need sample information. What is sample? Sample data. Sample data is start with the sample size. In this case, the size is 45. Then you need the sample mean. Sample mean is given to you is 37.5 milliliter. Milli, that's it, per kilograms. And the standard deviation is given. The standard deviation is 6.70. You know, this is milliliter per kilogram. That's unit. So you want to do it with the confidence level of the 99%. 99%. So you have to find the marginal error. You have to provide this line or look for it and find it for any problem on the confidence interval. Okay, so you have to identify the type of the test that we're going to use. You focus on the idea. If the sigma is given is straightforward, otherwise the sample size. The cut for the sample size is going to be 30. But in this case, you say that the sigma, okay, sample standard deviation, 6.7 is known, and so z test or the z interval. Okay, so z test, call it z test. Z test or z interval can be applied or should be applied. Can be applied. That's the difference between this problem and the other one. So in this case, your E would be ZC. ZC sigma over radical N. You have to find the ZC. We talk about how we're going to find it. We give you the table. Remember, this is the table. You bring all these. Okay, a copy for your test. So that's a table to find the ZC. So C is in this case 99%. So this is 99%, and the critical value is 2.58. Okay, so C is equal to the 99%. So the corresponding number ZC is going to be 2.58. That's it. You go back, substitute to get your E. So E is equal to 2.58. 2.58 times it by sigma. Sigma is 6.7, radical N, and the sample size of the 45. That's it. Use your calculator to get this number. Okay, so this is it. So what I have is 2.58. 2.58 times it by 6.7. Okay, 6.7, and then divided by the square root of 45. 45. Oops, I didn't get it. 2.58 times it by 6.7. Okay, 2.58 times it by 6.7. Then divided by the square root of 45. Okay. $2.57, 2.576. So it's a 2.57. Okay, 6. You may call it, 2.6. So that give you a marginal error. So the E is equal to 2.6. Any question? Now we are ready to give you the interval. You know that the interval is what? Interval is mu is between x bar minus E and x bar plus E. Substitute. So it's going to be mu between x bar. X bar is 37.5 minus E, which is a 2.6. It's less than 37.5 plus 2.6. Okay, so your mu is going to be between, if you add these, 5 and 6 would be 11. Okay, 3, that give you 10, 4, 40.0.1. And over here we subtracted, it's a 2.6. So if you subtract that, give you 9 and 4. Okay, so it's greater than. Okay, I run that to the 35 and the 40 here. Okay, these are going to be the one, that milliliter per kilograms. So the mu is going to be between 35 and 40, but you have to make a comment. The comment is, something like, there is, how sure you are, 99%. There is 99% chance, 99% chance that the population mean, we mean the mean of those, what is that, blood plasma, is going to be, is between 35 and 40, the unit, milliliters per kilograms. And that, very nice, easy problem. But the important part is the test. Which test are going to use? Okay, which test are going to use? Then you can explain it, the problem that, you get to the test, and when you introduce the test, then you can use your calculator if you like to get the, or to go, if you want to check it. So to get to the calculator, you know that you have to go to that is going to be, you go to the second, and then you have to go to the test, or to the interval. Let's see. We give you the intervals here. That was, we need a Z interval. Z interval, we go to the second, to the statistic, go to the test. Okay, going to the test, then Z interval is number 7. Z interval number 7. So to the test, then the Z interval, then they ask for the information. They ask for the sigma. Sigma is 6.7. So that's a 6.7. Then they ask for the X bar. And the X bar for this problem is 37.5. 37.5, the sample size. The sample size are 45. 45, and then the confidence level is 99. We already got 99 here. So we're going to calculate that to see if this is correct. What happened to it? It was something wrong with my calculator over here. Okay. So that was the test. Then the number 7. That is 6.7. Everything is all right. 6.7, 37.5, 45, and doing the job. Yes, that's it. You see 34.9, which is like 35, and the 40.0773. Okay, a little bit different, but it's not bad. Okay, I just run that. So 35, 34.9, which is like a 35, and over here is 40.073, which is like the 40. We get the result right away. Okay, so you have to explain that, explain that the information, you see, you set up the test, So this is going to be the test that we're going to use. As soon as you get the z-test can be applied, then you can go to your calculator and give us the final answer. But as I told you the other day, if you just give me a number, yes, the final solution is 1 out of 10. But you have to explain it, connect the problems, okay? And it's not bad. Double check it and just do it for the time being. Because if you miss a number, then you miss all the grade. And when you write it down, if you miss something, you may get 8 out of 10. Okay, so don't risk it unless you are quite sure about it. So this is it. Any question? So that's a type 1. Sometimes it's going to be again type 1, but they may ask you an extra question, something to comment. You see, when you say I'm 99% that the mu is between 35 and 40, if somebody came, oh no, I believe it's 50. You say no, it's not 50 because it must be between 35 and 40. Okay, so sometimes they ask you some kind of extra question to guess, to comment on something. So that's why I give you another one to just make sure you get it right when we go to the to the next one. The next one is going to be again case 1. Okay, where did I get the ZC? You need this table. This is the one that I posted for you. We call it critical values. It's on the canvas. This is ZC, okay, the bottom corner. So these are going to be the percentage that will be given to you, 99%. This is ZC, 2.58. Okay, check this one. I'm already giving you all the paper. Just the front page, make a comment, make a copy and make them available to yourself. Okay, let's give you another one, number 5. It's the same thing, but they ask you to make a comment at the end. You see number 5. Talk about grading, your paper, your essays, etc. We have 40 English composition professors. Okay, and they grade the paper. They show that they spend on average 12.6 minutes correcting a term paper. Okay, so sample size of 40, and the mean is 12.6 minutes that they spend to grade your test. So we want to find the confidence interval, 90% confidence interval of the mean of all these, mean of time that all the professor would spend. A sigma is given to, so it's case 1. When you find your interval, then you answer the second part. The second part is if a professor claimed that he or she spent 30 minutes correcting your paper, we want to know what's going to be your reaction. Okay, is it true or not? So you do the first part and then you can make a comment on the second one. Okay, so it's again the same problem, but an extra one to practice. So we read the problem, we find out that we are interested in confidence interval for the mean. So we have to bring the information. The information is going to be what's going to be your sample information, sample data. The sample data starts with the sample size. We consider 40 professors, okay? The mean time that they spend to correct the paper is 12.6 minutes, okay, 0.6 minutes. So the sigma is given to, standard deviation for all the people is 2.5 minutes, and you want to test it at the 90% confidence level. So you need to find the E to get these numbers. Okay, a straightforward problem. So the solution is going to be simply, you check to see if the sigma is given to, yes, sigma is given. So it's a z-test. So sigma equal to the 2.5 is given, is known. Okay, it's going to be known, and so z-test. z-test can be applied, or the z-interval can be applied. So your formula is going to be marginal error would be ZC times S sigma over radical N. We have to find the ZC for the 90%. Okay, C is equal to the 90%. Again, you go to that bottom corner that we talk about it, you see 90%, 1.645. So so ZC would be 1.645. That's it. Any question? So make sure you have it from the canvas. That's ZC1. We are going to substitute here to get the E. So E would be 1.645 times the sigma. Sigma is 2.5. Radical N over 40. Okay, that's it. We get this one. Use your calculator to get this one. So this is it. What I have is a 1.645 times it by 2.5. 2.5, then we are going to divide it by the square root. It will be square root of 40. Square root of 40, and the final answer is a 0.65. Okay, it's 0.6502. So we call it 0.65. So that would be our marginal error. Any question? So get the interval. So the mu is between x bar plus E and the x bar minus E. You substitute, your mean is 12.6. 12.6 minus 0.65, and the mu 12.6 plus 0.65. We add them together. So over here we get the 5, 6, and 6, 12.13. And over here you subtract. And so that gives you 5. That would be 9 and 11. Okay, so this is going to be the case, 11.95, which is almost 12 minutes. This is going to be the interval that we're going to have. Even if you run that is something like 12 and, you can say 12 and 13, just keep it, doesn't matter. So you make a comment. So we are 90% sure, or one can say, or there is, the probability was 90% chance that the time that they have to spend, that the population mean, population mean of those are going to be is between, it's going to be between 11.95 and 13.25 minutes. Okay, so this is going to be based on this information. This is the actual times that they have to spend in order to correct your papers. Okay, that's part one. And the part two, the claim was 30 minutes. No, it's not true. So in part two, then you just write something nice. So 30 minutes is going to be mu equal to the 30 minutes is not in the interval. Okay, it's not true. It's not consistent. Don't be nice. Okay, so it's not consistent with the above interval, if you like. Interval. Okay, so when they claim it's 30 minutes, no, it can't be true, something like that. it can't be true, it's not consistent to the given interval and do that. Okay, any question? So that's case one, a straightforward case one, that the sigma is known to be able to do it. Now, there is one more problem for the case one, very easy one. We talk about that one first, and then we give a break, then we come back, we do the t distribution, which is a little bit more involved. Now, this next problem is, we talk about it if you want to do it practically. If you want to do it, what you have to do, you have to go around and pick a sample and collect the information. But the question is going to be, what should be the size of the sample? Okay, so this is the one that we call it a minimum size problem. So n is missing. They are going to give you the marginal error, but it's important to realize that this is the marginal sample size problem, and the way they express the marginal error, they use something like, the expression like within 5 minutes, $2, etc. Okay, so that would be your second problem on the confidence interval when the sigma is known. So this is problem number 6. And the problem number 6, you have to find minimum sample size. E would be given to you, okay? You know that minimum sample size for estimation, you know that, for estimation or estimating. So you can use the E formula and then solve for n, or just memorize this formula. N equal to, okay, it's going to be n equal to the top would be stay the same as we did before, ZC times it by the sigma, but you divide it by E, but then you have to square it. Because in the formula, remember, in the formula, there was a radical n. The things that you may miss it, you see, all of them are inside the parentheses, all of them. So you have to do inside first, you do the multiplication, you divide, then you square it. Some people, they miss this one on the test because they use the square for the top term only, which is not. Okay, so when you write it down for yourself, a square is on the top of everything. So you have to do the simplification first, then a square. Otherwise, it's a straightforward problem. Okay, so 3 numbers would be given to you: sigma, E, and the C. You have to find the ZC and then get back to get there. Okay, let's see what's going to move those 3 numbers here. This is number 6. An economist wants to estimate the mean income for the first year of work for college graduates who have had the profound wisdom to take a statistics course, of course. So how many such incomes must be found? How many? N is missing. So if you want to be confidence interval 95%, so C is 95, and you want to do it, so the sample mean is within 500. You see this expression within, give you the hint that this is marginal error. Okay, and the sigma is given to you. So this is how we're going to do it. As soon as they say how many, you realize that the N is missing. So N is missing. So you want to do it with a confidence of the 95%. So C is equal to the 95%. Okay, within 500 means E, marginal error, is 500. And the sigma is already given to you. $6,250. That's it. This is your information. You already got the formula. So you have to find the ZC. Okay, we go for the ZC first. So that's it. C is 95%. You go to that bottom corner. Remember, this is it. Again, ZC. 95. For the 95%, the ZC is 1.96. Okay, so this is how we're going to find it. 1.96 for the ZC. ZC 1.96. That's it. Go back, substitute to get N. So N is equal to, inside parentheses first, ZC of 1.96 times it by sigma. Sigma of 6,250. Then you divide it by E. When you are done, then you square it. Order of the operation. Make sure you don't miss it. Okay. Let's do it. Use your calculator. Make sure you get the same number. 1.96 times it by 6,250. That's it. Then divided by 500. Okay, that gives you 24.5. If you like, I write it down so you can double check it for yourself. It's 24.5 squared. Now I'm going to square this one. So 24.5. Okay. So that gives you 24.5. Something like with my calculator. It's going to be 600 something. 5 times that by 24.5. It's going to be something like 625. But remember, this must be round up all the time. Round up to the next nearest number. All the time round up. So you round it up into the 601. So we need at least 601 people, if you like, for our sample to get these numbers. Okay. Remember, you must round it all the time. And it's always rounded up because this is unit, this is people. You cannot have 625% of the percent. So make sure you round it up. Okay, so this is the at least minimum. This is the minimum size. So this means you can start with a 601 or anything higher, but you cannot stay with anything lower. Okay, that's why we round it up to make sure that we are going to be on the board there that we need it. Okay. This is the minimum sample size problem. So that will be a very easy problem. And you can do it right away with there. Okay, so that's it, 11:20. Give you 10 minutes, we come back and we do the T distribution. We have 2 problems on the T. We explain that one and then be done for those 11 questions. Okay, see you in 10 minutes. Okay, so that was the confidence interval when the sigma is known. So we're going to consider the next case. We're going to see what we're going to do when the sigma is not going to be given to you. So there are going to be two types of problems. The first one is the general one. The sample space would be a sample standard deviation would be given. But the second one is the actual case, the data values. So I'm going to explain the formula that we're going to use for this case. And then let me do it. Okay. So let's go back to my notebook. Okay, so that was the case one. Now the case two is going to be the problem number 7 and 8. You see, I explained the formula here. So in this case, the sigma is unknown. When the sigma is unknown, you check the sample size. Probably in this case, the sample size is small, less than 30. So to not be confused from now on, anytime the sample size is bigger than 30, we say this is the z-test, case 1. Everything related to the normal distribution, we use the z-score. But if the sigma is not given to you and the sample size is less than 30, then you cannot use the z-score. Okay, so if you have any doubt about the sigma, you look at the sample size. If a sample size is big, whatever it is, you can call it sigma. But it's going to be less than 30, and the sigma is not given to you. If there is going to be any standard deviation, that would be sample. Okay, so this is going to be a difference between the case 1 and the case 2 that we're going to consider for the rest of the course, because there is another concept that we're going to take that one after your test. So it's going to be the case. No. When yes, it is a t-test, of course. Okay, so if this is going to be the case, we are going to use the t-test. T-test should be applied. Okay, can be applied. When you do the t-test, so your formula is going to be changed. So the formula would be Tc, S over radical n. Okay, so the critical value is going to be Tc, and you have to go find it from from your T table. And this is going to be the T table that I posted for you. Okay, that's a T table. Okay, this is going to be your T table for this test. So the critical level, this is the critical level C. Okay, so this line only. The first two lines, forget it. We are going to get it for the final. So this is going to be 50%, 70%, 80%, etc. Then this column over here is the one we call it DF, degrees of freedom, because this curve would be different for different samples. So what we're going to do, we give you we give you the N. So you have to find the DF yourself. DF is N minus 1. So when you find the DF N minus 1, then you can find the critical values. For example, if the DF happened to be 13, and then you have the C of, you see, if you have a C of, let's say, this is the C with the 95%, you see, 95%, and the D of a 13. And there is a 99 and 99.9%. So if you get the 99% and the 13, you see you get the TEC here. So this is how we're going to find the T value from the T table. You need this one. In the case of the calculator, is T interval. Number 7 on that calculator was the Z interval. Number 8 would be T interval. I'm going to explain it when we get to the problem. Okay, so there are going to be two problems, 7 and 8. So in 7, straightforward. This is case 1. You read the problem, they directly give you you see in this case, this is about the number of the phone calls that we receive each evening, and mostly we don't answer. So a random sample of 13 evenings at a special family home. They find out that they get on average 5.2 calls, okay, each evening. So the sample standard deviation is given to you 1.9. We want to find the 95% confidence interval of the population mean of all those, phone calls that we receive each evening. So as you can see, S is given to the sample standard deviation, and the sample size is 14, which is small. So you are going to put the information together. So this is going to be the information that we have. We realize that again, the problem is the problem of the mean. Okay, but we need the sample information again. So sample information, sample data. The sample data starts with the sample size all the time. You have 14 evenings. Okay. And in this case, the sample mean is given to you. The X bar is 5.2. 5.2, we don't have the sigma, but we have S. S, the standard deviation of a sample, is 1.9. And you want to test this one. Find the confidence interval with the confidence level of 95%. So we have to find the E. See, so collecting the information, the difference is this one. In the previous one, sigma was given to, but S. Now you have to pick the proper test, and then you explain it, that N sigma is unknown. Sigma is unknown, and the sample size is small, N is less than 40. Okay, so t-test should be applied. T-test can be applied. So we need the TC. That's a formula, that's going to be E. Okay, this is it. Your E is going to be TC S over radical N. But you have to find the TC. So we get the TF first. You see N is, that's it. N is equal to the 14. So degree of freedom is N minus 1, which is 14 minus 1, which is equal to the 13. So you go to that table that we have. You see the table. This is the DF on the table. So you identify the 13. Then you go to the right and you match this one with the C of, okay, C of 95%. 95%. And you pick these numbers, that's going to be your TC. You see that is the DF of 13. You see DF of 13. And that's going to be your DF of 13. And you look for the 95%. 95% is here, you see. 95% and the 13. If you put them together, that's going to be 2.160. You see, that's one. DF 13, 95%. 2.16, okay. So this is 2.16. So your TC is going to be 2.16 or 160, which is the same thing. Okay, any question? So, TC is very easy to find. So you go back and you substitute to get the E. So E is equal to the 2.16 times a standard deviation, which is 1.9, divided by the radical N, radical 14. Use your calculator to get this number. So that would give us the marginal error. So we have 2.16 times it by 1.9. Okay, 4.1, and divided by radical or the square root of 14. Okay, 14, and the final answer is going to be 1.096. So I run that, and it's going to be 1.1. Okay, so this is going to be equal to the almost 1.1. So the marginal error is going to be 1.1 phone calls, if you like. Okay, now we are going to give you any question. Now we can give you the interval. So the interval is, as usual, is going to be x bar minus e less than mu and less than x bar plus e. You substitute, remember the x bar is 5.2. So it's going to be 5.2, 5.2 minus 1.1, and that is going to be mu, and the mu is going to be less than 5.2 plus 1.1. So you subtract this one, that gives you 4.1, and less than mu, and this would be 6.3, 6.3. So something like between 4 and 6. But you have to make a comment. Okay, your comment is going to be, we have a level of 95%. So there is a 95% chance. Okay, make a comment here. So there is a 95% chance that on average you are going to get this number of phone calls. There's 95% chance that population mean is going to be between, it's a phone call, so you just round it to the round number, whole number is going to be between 4 and 6. 4 and 6 okay, phone calls, and then you that. Okay, very nice method, and not difficult to do it, just using the table. And of course, you can check it with your calculator, or if you want to use calculator, you have to explain the problem first. Okay, you explain it, the t-test can be applied. Then this part, the calculation part, you can use your calculator, but you have to explain which tests are going to use. What is this problem about? We go double check it with your calculator. Okay, so we need, this is going to be the second. We need to go to the test. Sorry. Go to the statistic. Then that's it. The test, it's going to be a statistic, then the test. So we go with the test. Remember, number 7 was the z-test that we did. If you go down, okay, that's a number 7. Number 8, you will see the t interval. T interval. And then you click on the t interval, and there you are. They ask you for the statistics. Statistics would be the mean. X bar is 5.2. So that would be 5.2. Then S 1.9. So that would be 1.9. Then the sample 14, sample size of the 14. The level is 95. So level of 95. And then we are going to ask to calculate it. This is going to be the case. You see the interval 4.1 and the 6.2 or 6.3. That's exactly what we got here. 4.1, 6.3. That's it. 4.103 and 6.297, which is 6.3. Okay, so it's not difficult. You can do it. We don't mind if you do it. But again, explain the problem. What tests are going to use? What's the problem is about? And then for this part, of course, you can use your calculator if you like. Otherwise, it's easy problem. It's not. But don't miss it. The type of the test, the most important part one. If you use the z-test for this one, you are out. You can't do it because the sample size is small, less than 30. If this n was bigger than 30, although they say S, you can call it sigma. Okay, if this n was 50, for example, or 100, It's bigger than 30, we consider it to be good, to be the population. But when it's less than 30, you have to stay with the S and you get this number. Okay, that's a type 1. Any question? Now, there is going to be another one which is more popular, and that would take a little bit more time. The other one is the actual numbers and the situation would be described. Okay, so you have to do all the job yourself to get this one through. So you'll be given 2 problems for this one. The first one is like the one we did, and this is going to be the second one. What is the second one? The daily salaries of substitution teachers for 8 local schools are shown. So these are the salary for a substitution teacher for each day in dollars, $60, $56, etc. So what we'd like to do, we would like to find 90% confidence interval for the salaries. And so as you can see, this is a sample, it's a small sample. N is equal to the 8, and 8 is less than 30. So this problem can be done only by using the t-distribution. In order to use the t, you see you need the x-bar, sample information. You need the sample mean, you need the sample standard deviation. So you need the x-bar, you need the s, you don't have it. So first thing to do, you have to go and back and find those 2 numbers, okay? Again, you can use it right away, or you can use your calculator to get this number. So that's the idea of this problem. You're going to find those 2 numbers first, then you come back. Okay, so that's why it takes a little bit more time, and you manage your time to be able to do it. So this would be number 8, the actual problem. So in this case, again, the question is going to be regarding the mean. Okay, but sample information is not matched. Sample data, you need the sample size, that you have it, is 8. You need the sample mean, you don't have it, you have to find it. You need the sample standard deviation, you don't have it. Okay, you have the confidence level only, the confidence level of the 90%, and you have to find the marginal error. But the information that we have are going to be the numbers. Okay, that's it. We have a 60, a 56, 60, 55, 70, 55, and the 60 and 55. It can be done with your calculator to find it, but if you want to just to remind you the formula, this problem would be with us through the end of the course. There are a couple of other cases that we have 2 cases. The second case is this one, is one for the standard deviation, and there are 2 more. So on the final, we usually give you 1 that you have to go do and do this step. Okay, so calculator or otherwise, remember this is the way we did it. You have to find this 2 column, x and the x squared. So you have to just remind you when I do it with the calculator. So you're going to list these numbers. The mean is easy to find with or without calculator, but the sample standard deviation takes times. That is going to be the case. Okay, then you have to square it to get those numbers. So what you're going to do is you need to find this one, sigma x, and you need to find this part, which is going to be sigma x squared. Okay, and this is going to be the formulas that we have to use. And remember, x bar is equal to the sigma x over n, which is going to be sigma x over 8. You're going to find the sigma x. Then for the sample standard deviation, you have to use this formula. That's a sigma of x squared minus sigma x all squared divided by n, then n minus 1. Everything is inside this radical. If you want to use it manually, okay, that's the way we're going to get these numbers. No, you don't have to have any order. No. That's one. Yes, we are going to use the t-test, but you have to provide the information first. See, you have to provide this X bar. No, no order is needed. You just, using calculator, add them together, and to get these numbers, you know that your calculator would have different option to do this one, and then the squaring one, depends what you want to do. You have to put them into the data set of your calculator. So for example, I just use this one, easier for me. Okay, I just put the numbers in. You have to put the numbers in L1, remember, in both cases. And then that should give me the result, that's data. So what I want to do is, sorry, I have to start it over. This is the one that I have. So I go to the statistics. This is a smaller calculator. So with this one, then I go to the stat variables. You see quickly they give you the result. X bar of 59.42 and the standard deviation of, you see this one. I have all the information. 59.4, even give you those sigma one. If you like the sigmas, you can do it yourself. This would be, see, this would be 416. If you add them together, and if you add the squares, 24, okay, 886, 886, you square each one of them, then you add them together. If you want to substitute, but the final answer as we got it here, just straightforward. So the X bar, and that's it, give you the numbers here. So you must arrive at X bar equal to, I have 59.4. That's the X bar. And the standard deviation of the sample is going to be 5.2. Okay, so the calculator will give you right away the result to get these two, but if you want to do it yourself, you have to square these numbers, add them together, that gives you sigma x 24,886. You substitute to get these results. Okay, so now we can go back. You got that? 58.85. Yeah, you run that to get 59 almost. That is going to be, yes, 58. You have, yeah, if you run that to get 59, we go with 59 for all of them. It's okay. Standard deviation 5.08. Yes, it's going to be a little bit different between when using different calculators, but it doesn't matter. You are in the range. Okay. We pick one of these numbers, we go for it, and everything would be fine. So I stay with the 5.2, and I may call this one, 59 even. It doesn't matter for the last part that we have. Okay, so this is your extra job for this problem. And you have to do this one, then we have a problem. Okay, to go for it. This is going to be the case. Okay, you have to square this if you want to do it yourself. Okay, so now we have a problem. We have the case. So the case is that we complete everything we need. So we have the case of the sample size of 8, X bar of 59, standard deviation of 5.2, okay, C of 90%, and we want to find the marginal error. Okay, so the additional things that you have, and you have quite a lot in your book, because these are kind of the one that we may see it in when we want to apply it in, okay, kind of everyday life or in the application that we have. So that's why we want to make sure we are familiar. Okay, there you are. Now the decision. N is, of course, is less than 30, so we have to use the t-test. Okay, N is equal to the 8, is less than 30. So t-test should be applied. T-test can be applied. Okay, that's the one. So we know the formula, we have to find the TC. So you have to find the TC. So for the TC, your N is equal to the 8. You have to go with the degree of freedom. You see N is equal to the 8. So you have the DF, degree of freedom would be 8 minus 1, which is equal to the 7. So you go to your T table, and this is the column for the DF. Okay, column for the DF, you have the 7 here, and just keep going, match the top with 90%. Okay, so this is going to be the T table. The T table DF of 7. This is the DF of 7. Okay, DF of the 7 and the 90%. 90% DF of 7. Okay, this is going to be the number 1.895. Okay, 790. 790%. So 1.895. 1.895. So that would be the TC. So the TC is 1.895. Any question? So this is the case. Now we are ready, because the E is going to be equal to the TC times S over radical N. We substitute the TC of 1.895 times the S of 5.2 divided by radical N, which is going to be radical 8. Okay, use your calculator to get this one. So this is what we have. So 1.895 times it by 5.2, 9.8 divided by radical 8. So square root of 8. So I have 3.48. That's it, 3.483, 3.48. So 3.48. So that would be our marginal error. Then we are ready to give you the intervals. Okay, any question? Just check your calculator and make sure you have something similar to the one that I got. I think that's correct. Now we are ready to give you the interval. Okay, so what's going to be the interval? So the interval, this is it. Mu is going to be between x bar plus e, okay, and the x bar minus e. Then we substitute x bar of $59, okay, minus e, which is 3.48. And this is the mu, and 59 plus 3.48. That is going to be the case if you simplify it. So that gives you 2, 5. Okay, and 55.2. And over here, you get 84.62. Okay, it's in dollars. Like 56 if you want to round it up, or $56, and the other going to be now $62, $63. So that's going to be the average salary of those substitution teachers that we talk about it. You make a comment, the comment is going to be 90%. So there is 90% chance. There is 90% chance that the population mean is going to be between, okay, it's going to be between 55.52 and you can see it, $62.48. I'm going to check it. The number is seems to be right. I've done it before. That was 60. Yeah, it should be. All right. Okay, let's check it to make sure that we get it right. We go to the calculator for the t-test, remember? So this is going to be the case. We have to go and get the tests. That is the test. Okay, for the test, remember number 8, because the number 7 is the interval. You have to go for the t interval. That's it. Number 8 is a t interval. So t interval asks you for the mean. So the mean in this case was x bar is 59. Okay, that's a 59. Then we go for the standard deviation. Standard deviation that we find was 5.2. So that's a 5.2. Then for the sample, sample is 8. 8 is good. Okay, that is going to be 8 and the confidence level of 90%. So that is 90%. Okay, then you go to the calculation, calculate. That's it. 55.5, 62, like 62.4 or 0.5. Okay, it's almost like the one that we did, exactly like the one that we have. Okay, so this is what we got. Okay, that's it. So the lower one is almost the same. 55.517, we have 55.52. Okay, and the upper one is almost the same. 62.48. 62.48. Exactly the same one. Okay, so it's nice. You can check it with your calculator. Just do it with your calculator if you don't mind. But you have to set up the problem. Okay, don't just give us the final number. It's quite, quite a nice one. Okay, there you are. Any question? So you shouldn't have any difficulty to apply it. Okay, one from each. I'll have time, so I go back to the normal distribution one. I'm make sure that you understand it, because I did the second part, but I didn't do it manually. So I'm going to do it because the case with that normal approximation is the part that we call it correction for continuity. This is the part that you usually missed. Otherwise, everything would be happy. Okay, so this is problem number 2 that we didn't finish it the other day. So we're going to finish this one. Okay, so the question was, we have a binomial case, remember? We get a binomial case. It was about the people who passed their 90th birthday. Okay, so we want to check what is the probability that the number, what is the probability that between 25 and 35 people would have that opportunity, if you like, to get it true. Okay, so the situation is, we check. Remember, it's a big problem. It can be done partly by calculator. Most of it can be done manually, if you like. So the case was, there is 30.5% chance that somebody would get that one. So that's probability of success. Your N is 753 and the Q is 96.5. You have to check the condition. n times p greater than or equal to the 5n times q. You have to check these all, explain it. So if both of them are greater than 5, so this procedure is probable. Okay, we can do it. But we need a mu n times p, 26.36. We need the sigma, square root of npq, like your previous quiz. So we get the sigma and the mu. Then we are going to be in normal case. But you have to correct for continuity. What does it mean? This means if you are in a binomial, when we say r bigger than 15, you mean 15, 16, 17, 18, dot, dot, dot. But if you are in a normal distribution, if you're given this expression, you mean 15 is an interval, 15 and positive infinity. So you have to change it into an interval that covering the 15. To cover the 15, we can go only 0.5 to the right, 0.5 to the left. So going to the 15.5 or 14.5. But direction is greater than. 15 is greater than what? 15 is greater than 14.5. So that's why we use 14.5. Okay, so the direction must be consistent. We did this one. And this next one is the important part, is correction for continuity. You want the R to be between 25, 35. So X would be between, you see, this is your X, 35 less than what? Less than the bigger number, less than 35.5. Greater than what? Greater than the smaller number, 24.5. Just make sure don't miss this part. Otherwise, so from here that we didn't do it, we're just using the z-score. So the x1 is equal to the 24.5. So we get the z1, which is x minus mu over sigma. Okay, in this case, your x is 24.5, and the mu, remember what was the mu? Mu was 26.36. So minus 26.36, okay, divided by the sigma. And the sigma was 5.04. 5.04. Okay, you are going to get this number. So what's going to be the number? We have 24.5 minus 26.36, and then be divided by 5.04. If you divide it, that gives you the number. Remember 2 decimal places, so we run that, and that gives us 0.37. So it's going to be negative 0.37. Okay, so this is going to be for the first one. Question. To the other end, x2 equal to the 35.5. So the z2 would be, your x is 35.5, and the mu is 26.36 divided by 5.04. We give you just one part, not two parts. It takes time, but it's not bad. So it's a 35.5 minus 26.36. And then we divide it, divided by 9.14. Oh, I'm sorry. That's you are going to divide it by 5.04. So that gives 1.813, 2 decimal places, 181. So 181. Okay, so the problem now is going to be the problem of the z-score. Okay, the area are going to be, this is it, between negative 0.37 and 1.81. You know, we don't want, you know, to do that part with calculator, of course. I just wanted to show you. So you go to the Z table and you get these two numbers. Okay, this is going to be your Z table for the negative 0.37. That's a negative 0.37, 0. Okay, that's it. Negative 0.37, 0, 1, 2, 3, 4, 5, 6, 7. 35, 57. 35, 57. Then we go with the 1.81. 181. That's a 180. 1.8, 01, 9649. 9649. We subtracted, so it's going to be 0.9649 minus 0.3557. If you subtracted 7 out of 9, that gives you 2, 9, 6, and 6 would be 0. Okay, 0 and 6. Okay, so that's 7. So we have a 0.9649. And this is going to be minus, just double check, 0.3557. Yeah, that would be 60.9092. You have to check the other one too. Okay, so with this one, it's going to be 60.92% to get these numbers. The calculator one, we have to check it, the one that we talked about it the other day, to see that if it is going to be, it's too much, the difference. But we can check to see. Okay, so so that would be, if you want to do it yourself, and this is the way you have to operate. Or even if you want to use your calculator, make sure that you have to correct for the continuity. You correct for the continuity, then you'll be able to use that 24.5 and the 35.5. Okay, so the only difference, the only extra job is correction for continuity. Okay, you cannot use exactly the same number that is given to you. And that's it. Study your quiz. Okay, there was a couple of questions on the quiz that